In this lecture, we go to the unit number 3, pressure measurement. In the unit number 3, we will discuss about the mechanical pressure measurement device, Borden tube pressure kg, and the Bridgman kg, dead weight tester, and low pressure measurement. The low pressure measurement in terms of MC lead gauge, Peroni thermal conducting gauge, and the Kunsen gauge. In the pressure measurement, just to give the introduction about the how the pressure measure in the instrumentation. Okay. Pressure is represented as force per unit area for the particular device to the mechanical part. In the mechanical part of the process, have three important terms in the pressure. The first one is the absolute pressure, second one is the gauge pressure, and third one is the vacuum. The first thing, absolute pressure. It is referred to the absolute value of the force per unit area for the particular conducting wall by a fluid. The second part of the gauge pressure, it is represent the difference between the absolute pressure and the local atmosphere pressure. The third one is vacuum. It is represent the amount by which the atmosphere pressure exceeds the absolute pressure. From this definition, that the absolute pressure may not be negative and the vacuum may not be greater than the local atmosphere pressure. Okay. In the three term, we have represented in graphical way among their relationship. Let us consider this diagram. This diagram is the relationship between the pressure term, that is absolute pressure, gauge pressure, and vacuum. Here, in the first thing is absolute, is denoted by B, and this part is the in the beginning. Okay, in the beginning, zero absolute pressure. Here, this line, the dark line, is the atmosphere pressure. So, in between the zero absolute pressure and atmosphere pressure is the negative gauge pressure or vacuum. Okay. Above of the atmosphere pressure is the positive gauge pressure. So we have fixed the range from 0 to maximum level. Okay. So the maximum level to atmosphere pressure is called positive gauge pressure, and the difference between or in the distance between atmosphere pressure to zero absolute pressure is called negative gauge pressure or vacuum. Okay. Then some parameters we have taken the pressure means such as elevation, flow velocity, fluid density, and temperature or of the frequency important in the pressure measurement device. Okay. The system of the unit pressure is usually expressed in pound per square. That is the absolute. Okay. Cage pressure carrying the same unit is designed with the symbol B sign. B sign SIG. Sign means that is the signal. Okay. And the standard SI unit of the pressure is Newton per square meter. That is capital N slash small m square or Pascal. Newton per meter square or Pascal. Pascal means that is the PA. Okay. And then the pressure is frequently expressed in terms of the height of column of fluid which it will support at the temperature of 20 degrees Celsius. At standard atmosphere pressure, this height is 760 millimeter of mercury, having the density of 13.5951 gram per centimeter cube. Gram divided by centimeter cube. Okay. Some common unit of the pressure are, that is 1 atmosphere, that is a 1 atm is equal to 14.696 pound per square inch absolute. That is 1.01325 into 10 power 5 Newton per square meter. That is the Pascal. PA means that is the Pascal. It is equal to 2116 pound force per square feet. Then 1 Newton per meter square is equal to 1 Pascal. 1 atmosphere is equal to 760 millimeter of the mercury. The millimeter of the mercury is denoted by mm capital Hg. Okay. Hg is the mercury, mm is the millimeters. Then 1 bar is equal to 10 power 5 Newton per square meter. That is 100 kilopascal. 1 bar is equal to 10 power 5 Pascal. 1 microbar is equal to 1 diagram per square centimeter. That is equal to 2.089 pound force per square feet. It is equal to 0.1 Newton per square meter. Okay, that is 0.1 Pascal. Then 1 millimeter of the mercury is equal to 1333.22 microbar. It is equal to 133.3 Pascal. Then 1 micrometer is equal to 10 power minus 6 meter of mercury. The meter of the mercury is denoted by micrometer. Okay. So that is equal to 10 power minus 3 millimeter of the mercury. That is 0.133 Pascal. 1 torr is equal to 1 millimeter of the mercury. 1 inch of the mercury is equal to 70.773 pound force per square foot. 1 inch of the water is equal to 5.203 pound force per square feet. 1 pound per square inch absolute is equal to 6894.76 Newton per square meter. Okay. And fluid pressure, there is the fluid mechanical of the pressure result from the momentum exchange between the molecules of the fluid and the containing the wall. And the total momentum exchange depends on the total number of the molecules striking the wall per unit time and the average velocity of the molecules. For an ideal gas may be denoted by P is equal to 1 by 3 N M V squared RMS. Here RMS means root mean square molecular. Okay, root mean square molecular. Here P is the pressure. Here N is molecular density. M is molecular mass. Then V of RMS is a root mean square molecular velocity. Okay, so to find out the fluid pressure of momentum exchange between the molecule of the fluid and containing the wall of the pressure P is equal to 1 by 3 NMV square RMS. Okay. And in the pressure also we show the formula of VRMS is equal to, that is velocity, root mean molecular velocity is equal to root of 3 kT divided by m. Here T is the absolute temperature and K is 1.3803 into 10 power minus 3 molecules. Here K is called Boltzmann constant. Okay, K is called Boltzmann constant. The mean free path is defined as the average distance a molecule travel between the collisions for an ideal gas whose molecules act approximately like a Hilliard ball, that is lambda is equal to root 2 divided by 8 by r squared n, where r is the effective radius of the molecule and the lambda is the mean free path, and the mean free path, it is the approximately calculate in the calculation part. Okay, that is root 2 divided by 8 by r square n. And clearly the mean path increase with the decrease in the gas density at standard atmosphere pressure and temperature. The mean free path is quite small, of the order 10 to 5 centimeter. That is a range. Okay, in the range 10 to 5 centimeter. Sorry, it is not 10 to 5 centimeter, it is the 10 power minus 5 centimeter. Yeah, okay, the range 10 power minus 5 centimeter. At the pressure of 1 micrometer, the mean free path could be order of 1 centimeter. Okay, at the very low pressure means the mean free path may be significantly greater than a characteristics dimension of the containing vessel in the pressure. Okay, so that the relation for mean free path reduced to lambda is equal to 8.64 into 10 power minus 7. Okay, from the 10 power minus 5 centimeter. And also reduce the range of the lambda, That is lambda is equal to 2.27 into 10 power minus 5. Okay, that meaning is T in K and P in Pascal. Suppose a variety of the device are available for pressure measurement means in the static and the steady state, pressure is not difficult to measure with good accuracy. Dynamic measurement, however, the more reflex such that the influenced of the measurement strongly by the characteristics of the fluid mechanical studied by the instrumentation. That is, very accuracy result for the static measurement may be entirely unsatisfied for the dynamic measurement. Okay, so we should discuss some of the factors that are the important for the good dynamic response in the conjunction with the explosion associated with the different type of the pressure measurement devices. Okay, that's why we have studied the pressure measurement device with suitable of quantity in the pressure. Next class we discuss about the pressure measurement devices. Okay, thank you.